Give me 1 minute. Okay, so yeah, I will share my screen, and also I'll go through the collab notebooks which you are shared for the live session, and we will also go through some of the documentation. Okay, fine. I hope my
Excuse me, sir.
yes, yes.
Sir, screen is visible. I just wanted to ask that is this the first session of revision, or was there a previous session also?
No, no, this is the first session.
Okay, thank you.
Yeah. Okay. Yeah. So okay. So yeah. Uh, this collab notebook was shared with you all. So this was done during the live session in the last week 11 live session, and we have seen like if we change the number of centroids what will happen and all these things. And when we were looking into this implementing a k-means clustering, we found out that one of the crucial parameter for this clustering technique is the similarity metric, right? So what was the similarity metric which we are using? Mostly we were using by default for this live session, like the previous live session, not this live session, the previous live session. Anyone? Okay. Okay. So yeah. So there are yes, yes, please.
Sir, I'm not attending the last live session, which is on, I think, Thursday. Is there any recording available?
Yeah, I think it's already on the YouTube channel, so I have to check.
Because I seeing there, we cannot find there actually.
Okay, I have to check that then. Anyway, go through this documentation. So basically, for this um, mm, for that live session, we were using this Euclidean distance metric. So this that was one of the distance metric which can be used to uh, cluster data points into numerous groups and all. So yeah, we will go through each of these techniques one by one. So yeah, this was the documentation book for the k-means. I think this is size is pretty much good only. I have already zoomed it. So yeah, this was the k-means cluster class, and here we were mentioning the number of clusters and how to assign the number of clusters at the first place, like whether we are assigning it like in a uh, using some random wise or using k-means plus plus and all these things. And yeah, these were the number of other parameters which we can also change, and use no random state to like replicate the results, and all these things are there. So yeah, we will go to that distance part. So okay, Euclidean it's coming. Yes, anybody want to say something? Yeah, please feel free to unmute yourself, and then if you have any doubt, then you can just unmute yourself and you can say that. Okay. Mm, so I was just trying to find. Okay. So anyway, So as you can see over here, if you go to this area, right, you can see different uh, metrics which were visible at the side. So as you can see, some distance metric is there, some cosine similarity is there, Haber sign distance is there. So if you some I will just say some of, like, Haber sign distance is like the distance when you are calculating the distance between points in latitude and longitude. So that time, since latitude and longitude, these points lies in a spherical surface, so that at during those times we cannot use a straight line. So for those kind of points we have to use Haber sign distances. Euclidean distances, as name suggests, that it's just like some kind of norm. So uh, that is Euclidean distance. There are other similarity matrices like cosine similarities and all these things. Manhattan distance is also there. And yeah, this distances plays a crucial role in any kind of clustering algorithm. So it's recommended to go through all these metrics, mostly which are important, and these codes and all these things are as well. Okay, fine. So
Uh,
yes,
Sir, Harvey distance we use in K-means clustering.
uh, so so I was saying that however, these are different types of metrics. I'm saying different types of metrics which you can use. Maybe in the scalar library you have to have to check whether you can use it or not. But hover sign distance is a metric which you can utilize. I'm saying that.
For finding the distance between two clusters.
Two clusters, actually this is not two clusters. uh, when I'm talking about distance is
Between points.
between points. And Howard sign is also one form of like to technique to find the distance between points. The difference is that Howard sign is used to find the points when they lie on a spherical surface. So if you are trying to find the distance between, say, Mumbai to Chennai, how you are going to find out, like that?
Longitude, latitude, like that.
Yeah, but those the 2 points lie on the spherical surface, that is on the earth, right? You cannot just draw a straight line and measure the distance between these 2 points. Okay. Yeah, so these are the important matrices. But clustering, it's recommended to go through like how this clustering works, majorly in this sklearn part. Play with this Google Colab notebook and see if you change the number of clusters, the number of centroids, the standard deviation, all these things, and how these things works, lot how it changes the number of clusters and all these kind of things. Okay. uh, yeah, fine. And yeah, this is the centers, this is just pretty common, like no this the usage of each of these hyperparameters and all. But anyway, we will see if we can go through some. Yes,
Sir,
yes.
yeah, so we have to go through these different things given there, but still the in the syllabus, our syllabus K means and agglomerative, only these two are asked, right? For now,
Which one?
the K means clustering and the agglomerative, only these two are the one
E-
we should focus on, right?
yeah, but I am saying in k-means and the agglomerative clustering, I am saying that there are this metric part as well, right?
Yeah, yeah, yeah.
Yeah, I am
Okay,
saying beside the k-means part you have to focus on the inherent mathematical sections as well.
okay, okay.
Got it?
Okay, I thought so that you're saying the bisecting K means and all these given are
No,
these
no, no,
also
no. I'm not saying talking about for following all these techniques,
okay,
only
okay.
to do these techniques. But you, for the to better understanding, you need to understand how these things work
Yeah,
internally.
yes, sir.
Okay.
Okay. Okay, sir. Got it.
Okay. Yeah. Maybe here you can see something over here. So, yeah. Basically, you have to go through this documentation part, and the part which was not covered during the live session. It was, I think, it was. Yeah, so this is the inertia part. So inertia is also like the total the metric which you are getting, right? So try, it's having some metric, and based on the metric it's trying to find out some kind of loss function. So inertia is the overall end product which you want to minimize by using this clustering
Yeah,
technique.
yes, sir. So in the previous term questions as well, I also noticed that, like you're saying, the concepts behind these things are also asked as the,
Mhm.
like, what is this used for, or
Mhm.
what is like that. So we need to like brush up the MLT then concepts related to these,
Mm,
and then
re-
like concepts, right?
ex-
Recollect
uh,
them.
recollect them and how to
Yeah,
implement them.
yeah. How
Okay.
to implement? Okay.
Yeah. And the second thing, yeah, any more questions before moving forward? Okay, I'm taking this as yes. So uh, I will go to the next part, that is using
So,
MLP. Yes.
sorry, sir. So we like have to revise the entire MLT and then prepare for
Not,
MLP, or like,
I'm not talking about revising the exact or all MLT. You have to revise the particular sections which are
okay.
important for the for running this kind of algorithms and all.
Yes, yes. Okay, sir. Okay.
Okay. Okay. Yeah. So this is the thing. This is the MLP classifier which might be asked. So before going for what is this multi-layer perceptron or a deep neural network? Can just anyone can just volunteer to give a rough idea of how these things work and all, if someone has gone through this.
Multi-layer plus perceptron basically is a perceptron model, but what we do here is we combine multiple perceptron layers, add various nodes, create multiple layers, such that like the issue with perceptron is that it captures linear relationship only, but if we use a multi-layer perceptron, what's going to happen? We want to have different layer of perceptron models, and it's like so when we do that, we can capture more intense relationship, as especially if we increase the number of layers. Uh, so the only issue that was with perceptron was it was able to capture in a very precise way the relation between data, but the issue was it can capture only linear relationship. But you after using multi-layer perceptron, that issue was also tackled. So given the right number of hidden layers in a multi-layer perceptron, we are confirmed to get a precise boundary for the data.
Okay. Yeah, that's a pretty nice definition. Yeah, so that's pretty much the same. We have some kind of data which we want to map it to some kind of output, and we don't know the mapping function. So for that we are using some kind of neural network, and we are training that neural network to find out the desired output, or the at the end we are trying to find out the function which can provide us the desired output, right? And so so one of the part of this multi-layer perceptron is this adds a non-linearity term, right? And they have these activation functions, and also you have to know this uh, like how this multi-layer perceptron works for data sets. So not all data sets, but I will suggest you to go through uh, normal MNIST kind of data sets, as for example the data sets which we have looked over here, sample digits data set. So load digits, it's similar to some MNIST data set, but anyway, like some digit data set is there. So you can go through this data set. So what we'll do is that when these things are passed through multi-layer perceptron, it will go through each of this layer. It will do some kind of activation, it will do some kind of bias, there will be some weights over there, and there will be some activation functions. So different types of activation functions are there. Can anyone name some of the activation functions? Anyone?
There is one called ReLU that is most widely used.
Other?
Sigmoid.
Sigmoid. Why
Like
so can anyone just say like why the issues with the sigmoid activation functions? Anyone? Okay, so there are some issues with the sigmoid activation function, like sometimes it go there's some vanishing gradients and all these kind of issues are there. And so it is recommended to go through this activation function, their advantages, their disadvantages, and like why, when to use this kind the particular activation for a function for a particular task. And so when you are doing this working on this, okay, I think we have some examples for the multi-layer perceptron part. So as you can see, this is a pretty good example and this has some data set. So anyway, we will check if we have some demo data set here at the end. So yeah. So, okay, yeah, this is a pretty nice example on how to use multi-layer perceptron on MNIST dataset. So as you can see, these are some handwritten digits, uh, some 28 cross 28 pixel handwritten digits, and we are passing it through this multi-layer perceptron. And yeah, these are the parameters: maximum iteration, alpha, solver, and learning rate and all. So you need to understand the basic things like how this multi-layer perceptron works, like how the number of hidden layers, how many hidden layers are there, the number of terms times the multi-layer perceptron will try to train, or number of epochs and all these kind of things. The learning rate, I think learning rate everyone knows, we used for stochastic gradient descent and all these kind of things. We have looked into this learning rate thing. uh,
Excuse
yes,
me, sir. So
yes.
then, are we in this session? Are we going to discuss some of the like theory part of how this works and
No,
the
I am
explanation part?
in this part we are not going to the theory section. We are going more focused on what can come in the exam.
Okay,
So
so but
that's
we have to focus on the like the theory and the implementation mix, the like both of them,
not,
right?
yeah, so my task here is to like narrow down the set which is given to you. Okay,
Okay, sir.
yeah, so MLP, as I said, that MLP is a huge area, right? So number of this loss functions and all these kind of things, but I'm saying that which of the parts which are important for this upcoming exam.
Okay, sir.
Okay, yeah, so you can look into this, the loss functions, as how these things work, learning rate and all these things. If of course you will go through this SGD and all these things, if you have worked on those weeks, so you already know. So this those things are not important when you're talking about this MLP part. But of course the loss function, all these kinds of things are important. And when you are talking about the images, like how do you do the pre-processing, or how do you fed this part to the input layers, those kind of things are important, right?
Yes, sir.
So when you are when you are saying feeding this image into this MLP, so this will come handy, this reshape and all. How do you reshape this image to a vector, again from vector to how do you transform it back to a 2D matrix and all. Now if you have a RGB image, right? So if you have an RGB image, then it will be a 3D matrix. 3D matrix. So each will have some values in the red, green, and blue channel. So in those cases, how you are going to deal? So that part is important. Just talking about how you are going to feed this thing into the multi-layer perceptron. How does this loss function differ from each other, and uh, like what are the pre-processing steps which are important? So this is the narrow down part of the MLP.
So please share this link for this
Yeah,
page.
sure.
The
Uh, sure. So I can just share this in the chat, so please note it down. And Of course, you it's better to instead of not only going through the documentation, it's better to go through the this demo examples which are provided here as well. As you can see, there are some demo examples, MLP regressors and all. MLP regressor is also important, so you just have to go through some of the examples, and these examples will give you a pretty much good idea like how these things work. Okay, any question till this far?
So what about alpha? When we increase alpha or something, see the documentation. There is like when we increasing the alpha, the complexity is increasing. That's right.
What will happen? What is alpha over here?
Uh, Alpha, like when we doing stochastic gradient descent,
Mhm.
we put the like uh,
Alpha is the learning rate, right?
yes,
So if you have a very small alpha, so what will happen is that it will move towards this what they call this, the law, the global minima. Global minima, it will go towards this optimal value at a very slow pace.
yes,
And if you have very high value, then it will, of course, it will go at a high pace, but it may happen that it may shoot from the optimal minima. Then it will do some zigzag and all, and then finally reach to the minima if possible, like that. So they, these things I think we have seen in the, if you remember, in the SGD part, you were there, right?
yes.
So
But in MLP regressor
it
classification,
will, it will be same. Actually it will be same, nearly more or less it will be same. The alpha value, the those things are pretty much same only. The mass remains same, but there. Okay, if you have a very high alpha, it will shoot out. If you have a very low alpha, it will go at a very slow pace. And in those cases, what you can do is that you can add some adaptive alpha and all those kind of things.
so what is adaptive alpha? This was
I think here adaptive alpha is not there, but actually adaptive alpha means, okay, we will go through that in the SGD part. But anyway, if since you have asked over here, so uh, anybody wants to say like what is adaptive alpha, adaptive things?
Sir, I think when we put learning rate as adaptive, then
Here,
adaptive has some role to play in it.
yeah, so yeah, this is the thing, learning rates is constant, inverse scaling, adaptive. So when you are
On
kept at,
constant, on constant, adaptive alpha has no role to play. It's like defining it or not defining it. It is exactly the same. But when we put learning rate as inverse scaling or adaptive, then adaptive alpha changes accordingly.
at each time step t using an inverse scaling exponent of power t, learning rate in by power t, power of t comma power t, power of t comma power t, and power t we have mentioned over here, zero point 0.5, its default
And
value.
so,
Yeah,
do we need to also have to learn about other solvers like Saga and others?
saga and all, saga, I think it is, who is asking by the way this question?
Harshvardhan.
Okay, saga and all we will come to the other part when we are discussing on the week 4 and week 5. But yeah, saga and all these kind of things, not completely, but little bit is
A bit,
important. Not
a brief knowledge will be fine,
brief
basically.
knowledge will be fine. Yeah,
so sir, all these parameter we
hmm.
through we see all through like SGD regressor type.
Yeah, SGD regressor also, if you go through the documentation, you will see, except for this part, and I think this part,
Yes.
this, and yeah, batch size is also there. These things will be similar because at the end it is using this stochastic gradient descent, right? So though these are the important parameters which are required for the stochastic gradient descent.
So
Okay.
one question I want
Yes.
to ask, sir, when we doing MLP regressor, I'm seeing somewhere a given activation is equal to ReLU, but they ask at the end activation is like logistic, like it is given in some question.
Yeah, so activation you can change over here, right? There are, that's only I said that there are, you have to know the different types of loss function. That part is important.
Yes,
So I am
and
let's
activation when we ask what is after that.
okay. Let me go to that part. So when you are saying, so this is the part you are saying, right? Activation function. Yeah. So this is these are the activations and logistics. So some application may need a logistic regression. So for that time, for those kind of application, you will use this. If
Yes,
some application needs a ReLU, you will use this. So I'm not talking about like a you have to know the application. You have to know when to use ReLU, when to use TANH, when to use logistic identity and all. You just have to have a clear idea of this loss function, that these loss functions exist, what are the benefits and all. This kind of things are important. I'm just talking about that. Okay.
okay. If it is giving activation is equal to ReLU, or we find the answer, we find the what activation is, then there is given like answer is uh, logistic.
Hmm.
How to find means regressor already MLP classifier regressor already taken. Which one is? Uh,
uh, Default you are saying
yes, yes.
default. uh,
Because in one question in practice assignment something,
mm,
let's see.
yeah, the default
I'm
one is
confusing.
ReLU.
Like default
Default.
is ReLU, but when we find the an activation, there is answer is logistic
Okay.
estimated.
Okay, so that will need like I can't comment unless I know like what is the question over there. Maybe it requires the logistic function. That's why you have to use that, because maybe those areas ReLU may not work because of that, or maybe the question have asked like to implement a logistics activation over there because of that. So if you can just tell the question, like then it will be helpful.
Yes.
Yeah, I can wait for 1 or 2 minutes then.
So there is a question in activity question 11.3 where activation is given ReLU and some solvers alpha, some
Mm-hmm.
estimator is given, and then where xy are the training data.
Mm-hmm.
Then we output the CLF dot out activation,
Mm-hmm.
where the answer is logistic. Even an activation is given in ReLU. Activity question 11.3 eighth question. That's why
Okay.
I'm confusing. So,
Okay, let me check. Activity question
11.3.
11.3 and then
Question number 8. And same for 9 also. I can't understand how to find the end layers.
just a second. Equals to this 8 and 9.
Even so, seventh question also regarding finding the N output activation.
Yeah, I think I have to check this two questions. It shouldn't be like that, but anyway, I have to check this. Okay.
So how to find these questions? How to get the answer? That's
Yeah, the basic thing is to you have to yeah the basic thing what I was saying is to if you want to know how did to tackle this question, you have to uh, go through this examples, not the documentation, the examples which I just pasted out in the mm, chat chat window. This thing is there, right? At
yes,
the end you will see some examples are there, right? Here at the end you can see, right? Some examples are there. So
yes,
better to just glance over the documentation, how these things are working, like these things. No, I'm saying that first go through the this documentation. What are the parameters and all these things which you can put into this MLP classifier, and after that go through this. Sorry, yeah, go through this demo examples, classifier comparison, these things, whichever thing you think could be useful, because all these things are like could be useful, but now you have to judiciously use your time, and whichever you think will be fit for you, then just go over it and just have a look on how these things are working out over here. Okay. Yeah, that's the thing. Yeah, any more questions before moving forward? Okay. Okay, fine. Yeah. Mm, okay. Just so we will go to the other week. Okay.
Okay, so we're done with week 11, right?
Yeah, we are done with the week 11.
Okay, so then let's quickly go through week 10 now. Okay, so coming to week 10, so you have voting, bagging, random forest, and boosting. So largely these are the four topics that you have. Coming to how you are supposed to prepare for this, the general idea is first you can go through the slides a bit, know the general working of a model, like roughly speaking, how does a boosting model work, how does a bagging model work, how does a random forest model work. So the general idea about all these, we have previously discussed these in live sessions, we've seen this in the previous courses. You just need to have a high level idea. Once you do that, you can go to the documentation and read the different parameters that it takes and also try out an example. So that is the best way to learn. So since this course largely deals with practical stuff, so the idea is that you'll see how these implementations are done through sklearn. Try out a small thing on your own in a collab file or in any of the notebooks that you would want. Tweak different things and see how the model varies. So specifically in week 10, we discussed this very much in detail. So if any of you are not clear with how the voting classifier works, I would recommend going back to the live session in which we covered this, the way the voting classifiers work. And as is a revision session, I'm just going to tell you that this is one of the important parts. So how a voting classifier works and the different voting styles it takes. So it takes either voting style as hard or soft, and depending on what we pass here, the way the model works will be different. So it will be slightly different for classifier and slightly different for regressor. So the general idea of how voting classifier works, if you don't know, go back to the videos and see. So likewise, you can do the same in the documentation. You can see that it takes in these different things. It takes in estimators, it takes a style of voting, and if you want to provide weights, then that one. N jobs, flatten transform, and verbose specifically are not so important from an exam point of view, right? Okay. So these are the ones.
Explain what verbose does.
Sorry.
Can you briefly explain what verbose does?
Yeah, so for all these things, you can read this in the documentation as well. So in this particular case, you can see it is simply a matter of how much time is elapsed. Now, N jobs is so that you can run things in parallel. Flatten transform happens is how do you want the output to come out. So depending on your voting style, it can come out differently. So as I mentioned, these three things I would say you don't need to focus on so much for this particular test as such. However, these three parts are important. The how the estimators, how it takes in the estimators, what is the type of voting it takes, and what are the weights that are given. So for example, in the case of hard voting, it is simply a majority value directly. So if I take a classification problem with say 5 models, and let's say it's binary classification, if 3 models predict one class and 2 models predict the other, I can with hard voting I can simply with weights being none, it takes the majority. Since 3 models say class 0, that is what will end up being predicted. However, I have the option of giving weights. This will make sure that whatever is suggested by a certain estimator will be higher. Like for example, if I have 5 estimators, then I can pass in 5 values under weights. You can see that also here. The sequence of weights or class probabilities, and its shape is number of classifiers. So if I have 5 classifiers, I can pass in 5 values of weights, and depending on that, how my hard voting or soft voting setup changes, it will depend on that. So once again, this is important. Know how this works briefly. Refer back to the live session if you have any doubts regarding this. So voting classifier and voting regressive. Then we go to ADA Boost. So ADA Boost, once again, know how it works briefly. And so you can start with giving an estimator. So usually it takes the base estimator as a decision tree. Here you can try and modify the decision tree itself as well. So now here decision tree with max depth 1 is what it takes. So you can inside decision tree when you initialize, so you can write estimator is equal to decision tree here instead of none. You can instantiate a decision tree object, and there you can pass in the parameters if you want a higher depth or if you want more sample split, and basically however your decision tree work, all those parameters you can pass in over here. So that way the estimator will change and how many estimators you want and the learning rate itself. So the learning rate is the weight that is applied to each classifier, and this is how many estimators you want. So once again, if you guys have used ADA Boost a lot, you'll see that there is a common problem that we experience when we try out ADA Boost. Does anyone know what issue comes up when you use ADA Boost?
Time taken to train.
Okay, time taken is one. What else? Okay. So one of the sort of common things, at least when we try out this directly, is that sometimes a model can tend to overfit with data boost classifier. So you can think about what are my different options. So how do I sort of change this particular setup so that I can prevent my model from overfitting? Okay. So that is how data boost classifier works. And then we'll go to bagging classifier. So in the case of bagging classifier, once again, it is one where we take different sort of base estimators, and each of them can work on one particular subset of the data. So for example, let's go over these parameters here. So the first is what is the base estimator you want. So we can start with decision tree. This is how many of them do we want. So we want 10 of them. And this is how many samples are supposed to be taken in each of the base estimator. Now, do I need to use the entire data set or not is the question. So in the case of bagging, which actually stands for bootstrap aggregation, so even if we have a smaller data set, we can try and take out only portions of it and then treat that as my entire data set. So for example, I have say 1,000 points. So I'm going to create a new data set where I'm sampling 1,000 points. So this I can do with replacement. I don't have to always use the entire data set. So this is like creating a new sample. Okay. So this one says if max samples is 1, from the entire data set, we are going to take that many samples. Now, if I give a value saying, just take say 0.8 or something. So if I add 0.8, then x dot shape 0 is nothing but the number of rows. So 0.8 into how many ever rows are there. So if say this was 10,000 and if this was 0.8 into 10,000 will give me like 8,000. So for each of them we'll end up drawing 8,000 samples. So all your 10 estimators will now have 8,000 samples, and based on that it will do its training. So you can similarly do with the features as well. So this is how many features do you want to take in each one. With that also, once again, you have a choice of either taking all of them or taking a portion of them. Then we come to the idea of bootstrapping, which is what this is primarily built on. So whether you want to take these samples with replacement. So now this is again coming back to the same example. If I have 1,000 samples, and if I tell that you need to take 1,000 samples, so you have those 10 estimators, I want to take 1,000 samples for each. So rather than taking the whole data set at once, the exact data set as it is, I'm going to keep drawing samples. And in case I take one data point, there is a chance that I can take it again because I'm drawing with replacement. Okay. So, however, if you set it to false, then the replacement is not being done. If I draw a sample once, that is it. There is also the case for bootstrapping of features,
So,
whether you want to do it. Sorry, is there a
Excuse me,
question?
sir.
yeah, there's a question. I wanted to ask, like, if we want a more diverse model, a more diverse data set to train our model, should we put bootstrap to false, or should we put bootstrap to true? Like, I think it should be false, because if we are not taking the same data sets again and again, then our model will get trained on a more diverse data set. Uh, but when there was certain PYQ, and there it was written that bootstrap should be set to true if we want a more diverse data set. So I want to know if there
Yeah,
was
that
some
is
error
that
in
is
the
true, right? Because see, if I am going to end up using the entire data set as it is, each model is learning more or less the same things.
sir. But okay, sir. So if we set bootstrap to false, instead of portion of the data set, we take the entire data set.
Yeah, so the number of samples you take will be the same. It is just that now your model is being trained on a different subset of the data. So it is not looking at the entire data set in one go. And each of these models will be looking at different versions of the data set. So what everything learns will be different. So if you
But
remember
what
in
if we set
this,
bootstrap to false? What will
yeah, if you
happen then?
set if you set bootstrap to false, here the like for example, if you go back to this one, here the sampling is not being done with replacement. So it is basically without
But we
replacement.
are
And
still
if I
sampling data, no? So
Yeah, we are
that's
sampling, but here if my max samples is same, then everything is again taking the entire
yeah,
set
yeah.
of
If the
points.
max sample is same, and what is the default value of max feature?
So max features is again one itself by default. So here if you
So like
want,
it will
if you
take just one feature.
no, one is that I want all the features in the data set.
Okay, 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 sir, got you.
Okay. So if I want a percentage of the features, then it does this one. So if I say give me some 0.5, then it will take 50% of the features.
Okay,
So,
so if
sir,
our main feature,
sorry to interrupt, but I have a similar doubt then that if we
Okay.
set bootstrap to false, then and at the same time we have set not set the max samples to be the default, we have set it like 0.8, like you said. Then
Yeah.
how will it take 8,000 for each if it's not doing it by replacement?
So here Yeah, once again, if for each this one I have 10,000 points, right? I'm saying take 8,000, and you have to also consider the case where these things are valid. So if I don't have my max samples as one, can I even set my bootstrap to be true or false? So if I set a different value, so these are combinations is what I'm saying you should work out. So go through
okay,
this
sir.
documentation, take this example, try out these different things. Another thing that you can do is building upon what I think it was Shwardhan who asked. So you
Yeah,
can
yeah,
set this one to be true, but
true,
set the
yeah,
bootstrap features to be a percentage. So see what happens then.
yeah.
Okay.
Uh,
So you cannot always use all the settings. Like for example, here, okay, one of them I'll directly tell you. So it is given here, right? So this out of bag score is a generalization error, and you can only do if there is bootstrapping. So because in bootstrapping, what am I doing? I'm taking only a portion of the data set in one set. Like for example, I'm taking say 8,000 points. There are some 2,000 points remaining that I've not looked at. In my original data set, 8,000 points went, 2,000 points remain. And now whatever those points are there, I can even try and get a score out of that. Right? So that is what this OOB score does. And warm start is again if you whatever you have done in your previous fit, if you want to continue using it. Once again, verbose and end jobs you don't need to focus on so much. Random state you have seen. So coming back to the beginning, I would say in the case of bagging classifier, understand what these many features do. So roughly what these things do, and a general idea of how it works and what settings are valid when. Like a simple one directly was that your OOB score is only valid if you're taking if your bootstrap is equal to true. Because think about it, OOB score is your out of bag score, and it only makes sense if I have separate portion of the data set on which I have not seen anything. So if I have not set my bootstrap equal to true, that means I'm having a look at the entire data point. So there is nothing I have that the model has not already seen. Okay. Beyond this, you can explore some more. Random forest has. Okay. Was there any other questions on bagging? Okay. All right.
Sir,
So
I
coming.
think I didn't understand. Oh, out of back score. Can you just once again?
Okay. So can you tell me how bootstrap aggregation, how bagging works roughly?
Yeah. So there are, suppose we have 10 estimators, so we will create 10 bags, and in those 10 bags, we will sample with replacement from the original data set. And there might be some of the data points which are common, or which are repeated. And then we train 10 models on that, and then we aggregate the answer.
Okay. So if you take your entire data set, for each model, you're not always going to use the entire data set. You're only going to draw a number of a portion of samples as specified here. So now if I have 10,000 points and if I take only 8,000 of them for my first model, there are so many remaining points that I've not even seen, right? So uh, say let us take this case where bootstrap also is equal to true. So I'm drawing with replacement. And when I'm drawing with replacement, and if I am taking, let's take the case that I have 10,000 points, I'm going to draw 10,000 points as well. But I've set my bootstrap equal to true. So now, if I am drawing samples with replacement, will all the data points in the data set be seen?
No.
Yeah, there are some data points that are not seen, right? So you recollect from MLT, so the prof talks what is the percentage, what is the chance of a point being picked and not picked. This is basically that idea. Now, if my data set has 10,000 points, and when I am drawing 10,000 points, if I am doing it with replacement, there will always be a number of points that are seen again and again because I'm drawing with replacement. So they come multiple times. Likewise, there will be a set of points that do not come in this particular bag at all. In this whatever sampling I've done, there will be certain points that are not there. So whatever I've built my model, so these points that I've not at all seen, these are my out of bag samples. And I can use this particular one to tell how my model has learned. So basically, this is like having a validation set while sampling itself. While training the model itself, within that itself, I'm sort of getting a generalization error. Does that make sense?
Yes.
Okay. So yeah, once again, if any of these are not clear, right? So this is the process that I recommend that you follow. See a high level working of how the model, basically a high level overview of how the model works. Have a look at all its parameters. Try and understand what these parameters mean, and then try out a small example through Colab. Change different settings, see what works and what doesn't. So this is a setup that you have to go through. And again, in the next session, anyway, if you have any questions amongst all these, you can bring it back up then as well. Okay. So finally, coming to random forest classifier for this week. So this has some common ideas in the case of bootstraps and OOB score. There are a few other parameters that you would have seen in the case of decision trees. So this will be your criterion, your max depth, your max features, max leaf nodes, and so on. So once again, there are plenty here. There is also this of pruning and class weights and so on. There's also the idea of number
So
of
can you
estimators.
briefly devise pruning once?
So these things again in the revision session, I cannot cover all these. So this is covered in the live sessions then. So roughly, if you want, so even with if you come back to pruning
Yeah,
here, this is about you build your tree and then you start removing parts of it. So that is called as pruning. Okay. So there are two ways to do pruning. So one, the post pruning is where you finish building your model and then you start removing parts from it to prevent overfitting. Okay, so you can see that is mentioned here as well. So to prevent overfitting, so there are already existing ones such as minimum sample leaf and max depth. But then, okay, here there is one more. Yeah, the the pruning technique here that you have is the cost complexity pruning. So which is what is set by CCP alpha. So if you've not already seen pruning, this might not be a good source for it. But roughly said, if we have a look at a tree, let's see if we have, okay, so this is probably one tree structure.
So I know the basics, like pruning is a technique so that we prevent our model from overfitting, but I don't know how exactly it's implemented. Like its implementation is what I have doubted. I know
Okay,
how it
so,
works and what is its function. I
okay,
just
so
can't understand how do we do it. Like, do we use a grid search or do we do
yeah,
it
no,
manually
for
changing?
this particular one, I would say, once again, it is a little beyond what we have covered in this. But the general idea is that you go on cutting these leaf nodes depending on the values that you are
Manually,
giving here. Okay. So
manually or using some technique.
no, this is not manually. There is an inbuilt method that this follows. So if we come back here, so minimal cost complexity pruning. The working is given here. This is a bit beyond what we have seen. If necessary, I'd say
Do
you
we
go
need to
through
go
this.
to this documentation or like is it beyond our scope?
Yeah. So for an exam point of view, you don't need to go through it,
Okay,
but you
sir.
should just know that this is one where you can get your tree to be made smaller through pruning, and that it
Okay,
can help with something like overfitting. Okay.
okay, sir.
So once again, the important ones here are, these basic ones you've already seen in decision tree. Then the idea of randomness. So why is random forest classifier? Why is there? What is the randomness that is there in random forest classifier? Any answer?
Yeah, so the thing
The
is,
same
like
nature of the
it
classifier and
overfits
the
on the
features
data.
are
Yeah,
the
Sorry.
Tarun, sir.
features are different in classifier.
Okay, you're taking different features. Okay, any other answer?
Yeah, sir. So the problem with random forest classifier is that it overfits on the data. We don't want it. So we have two options. Either we can take splitting criteria as best, or we can choose it at random. We choose it at random so that our model does not learns too much feature from the training data. So the chances of overfitting are less, and it can perform better on test data. That's why we
Okay.
use
Okay, so
and
the
random.
and it's
general idea of,
it
yeah,
uses
sorry.
decision stumps it uses decision stumps instead of decision trees.
Right. So with all those, the general idea of randomness again comes from this itself. It is your OOB score, bootstrapping, and max features and all that. So every time you build a model, so you can, yeah, so this one. Every time you build a model, it is not necessary that it is going to look at all features. It's not necessary it is going to look at all samples. As one of you mentioned, we are looking at decision stumps. That is why everything that it learns is not the same. And the general idea of randomness comes from this idea of bootstrapping and OOB score and such. Okay. So this is basically the important things that are there from week 11. We saw voting classifier, that once again it's covered in depth in the session. Go to it if you did not get. Then we saw ADA boost, then we saw bagging, and now random forest classifier. Know a high level overview of the model, learn the different parameters it takes, try out different examples to see how things change. Okay, so that was week 10. So here you will see again the same parameters. So for example, yeah, one of the points I mentioned, it's there from the documentation, it's there here as well, that you can get the OB score only when bootstrap is equal to true. Okay, so this is quite similar to what you might see in the documentation, but more importantly, try out these things. Now coming to week 9, you have decision trees and the evaluation metrics here. So decision tree, it's quite straightforward. So depending on uh, how you want to split it, whatever you take as your index, uh, based on based on the information gain, it is going to make a split. So the idea is to keep reducing the impurity for each node. Okay. So once again, the same idea. Know a high level overview of how you have the points first in the beginning. You ask a question on a feature, and depending on the answer to it, you start making a split. And as to which question is good, it does based on information gain. So here specifically, we use this as the criterion. So you have Gini, entropy, and log loss. You don't need to know in depth the math of all these things. You don't specifically need to know how these things work. It's always good to know it, but from this exam point of view, you don't need to force yourself to know these things right now. But you should, however, know that when it comes to criterion, these are the things it takes. When it comes to splitter, it can go with either best or random. Okay. So this way, you should have an understanding of the parameters and what are the different changes. Like if I have no value for my max depth, what is a potential problem with decision tree? If I keep my max depth as 1, what will it end up doing? So basically, these are the ideas of your overfitting and underfitting. Okay, roughly this way you need to know how the
Sir,
model works. Yeah, sorry, please go ahead.
can you just briefly explain two parameters? One is minimum sample split and minimum sample leaf.
Okay, so minimum sample split is if I want to ask a question. So I'm going to say, let's see if we can get to a tree. So roughly, I'm just using this image for reference. Say I am at this particular node here, and I have say some 10,000 points. Now I ask a question and say some 9,900 points go here and 100 points come here. So in this particular node, I have 100 points. Now, however, if I want to say that if I take my minimum sample split to be something like 500, then it says that I'm not allowed to split this further. So if I want to ask a question and split my data set based on whether it answers yes or no, it has to have some minimum number of points. So that is what minimum sample split is. So at the minimum, if I now the base value here I think is 2 for it. Let's just have a look at it. Yeah, so minimum sample split is 2. This basically says before you ask a question, there have to be 2 points. So yeah, depending on the answer, either both points might go to one side or one might go to one, one might go to one might go to the other. But if you see this other one, which is your minimum samples leaf, it says if I have to call it as a leaf node, then it has to take in at least 1 point. Okay. So that way, if finally you know your internal nodes and your leaf nodes. So if I'm going to call a node as a leaf node, then at the minimum it should have 1. Now, when would it make more sense is that to prevent overfitting, I might tell that your minimum samples leaf should at least be 10. That is, if I don't have 10 data points, then I'm not going to call it as a leaf node. Likewise here, to make a split, which is your minimum sample split, I'm going to say that at the minimum, you're supposed to have, like say, some 50 points. So if there are no 50 points, you don't make a split. Is that okay?
Yes, sir, understood.
Yeah. So once again, these things you can experiment. So in the live session, I also showed how you can print the tree, like how you can visualize the tree. So you can put minimum sample split as say some very high value, like 100, 200 or something. And likewise for, one second, likewise for minimum samples leaf, you can give a high value. And then when you plot the tree, you'll see that the size of the tree will be very small because you're not allowing it to make splits and grow further. Likewise, as you keep reducing this value towards values like 2 here or 1 here, then you'll see that your tree is going to grow longer. Okay. Yeah. Please go ahead.
Sir, I'm a bit confused about this minimum weight fraction leaf.
Okay. Yeah. You want to know what this one does?
Yeah.
So this one, you can read this one here. What it says is the minimum weighted fraction of the sum of total weight of all the input samples required to be at a leaf node. So this is here you have one more parameter for it. It is called, there is one option to provide weights for each sample. Let me see if it's there. Yeah, so one of the parameters is that you can give in sample weights. So if you give in sample weights, what ends up happening is that your samples also you can give them some value. Now when you come to this particular one here, this particular parameter which is your minimum weight fraction leaf. So this says when you sum up all the weights of these samples, what is the minimum value I need to have to call it a leaf node? So that is if my samples end up having very, very low weights, say some values close to 0, then even if there are many points, I'm not going to bother calling it a leaf node. I'm just going to ignore it. So this says at the minimum, I should have so much weights for my samples when I sum it up so that it can be called as a leaf node. Okay.
Okay, sir.
All right. So with decision tree, criterion is important, splitter is important, max step, minimum samples, leaf, minimum sample split. Then max features and roughly CCP alpha. So these are the ones I would say are somewhat important. The pattern remains the same. Know the basic working of the model, know the parameters, know what values it takes, try out an example. Okay. So that was decision trees. The other important part here, I'm not going to cover it now, it is all these evaluation metrics. This is very, very important. So given a confusion matrix, you should know fully well how to interpret it and how do I get the precision recall, the true positive, the F1 score, what are the true negatives. So you can go through all these videos. Those are short videos on all these evaluation metrics and these are important. Even for multi-class setup, you might be given a simple numerical for which you have to calculate some evaluation metrics. Is that okay? So once again, if you guys have any doubts on all these, we'll be having one more session. So make sure you go through all these, everything from your end once, and then those specific doubts you can ask in the next sessions as well. Okay. So then we come to week 8. In week 8, the important parts that you have are support vector machines and k nearest neighbors, and a bit about softmax regression. So we'll have a look at these three things. So in the case of support vector machine, roughly I would say know what are the values at these parameters. So you have the parameters C, kernel, degree, and tolerance. So roughly these are the important ones. And things that you need to understand is now C we know is the regularization parameter. So how does it change when I change the values? So what ends up happening? Is there more penalty? Is there less penalty? That is one thing. Then specifically, what are the different kernels it takes? You will not be asked for a mathematical value or something as to like, how do these kernels look or to give any details about this, no theoretical question. But you should know roughly what are these different kernels and which ones does this particular method take. Degree as well. Now this is one more point. So if you see degree, you should understand that it only makes sense for a polynomial kernel. So it doesn't make sense if any other kernels are given. So likewise, what are the values gamma takes and a bit about what is tolerance and class weights. So these are ones you have seen in different models as well. So briefly, that is support vector machine. Your important ones are once again the regularization parameter, the kernel, the degree, gamma, and tolerance and class weights. Okay. Then we come to k-neighbors classifier. So in the case of k-neighbors classifier, the important ones will be number of neighbors, weights, and say the metric itself. So can someone tell me roughly how k-neighbors classifier works?
So
What
we'll
K-neighbor
look at
classifier?
it.
Yeah, Talangsi.
So it will look at major of its neighbors, and if we suppose the number of neighbors are 5, it will look at the majority of the votes there, and it will choose the class
Okay, and
depending on
how does it find who its neighbors are?
by when we allow a distance such as the squared distance or the Euclidean distance.
Okay, so that is kind of the important part here. Basically, you need to know what are the different evaluation metrics, distance metrics it can take. So Euclidean is 2. There's one more called Manhattan, which is 1. So that way, depending on it, these things will change. So with this also, I will say go through the documentation. Like for example, here there is a power parameter for Minkowski metric. So primarily, we don't vary these things too much. But you should make a note that even if this is Minkowski, depending on what power parameter I give, it will change what is the distance metric that ends up being applied. Okay, and roughly as I mentioned, so we find who are my closest neighbors, and then based on that, I take the majority vote in the case of say classification. All right. So can someone tell me what are some advantages and disadvantages of k-neighbors classifier?
The biggest disadvantage is like choosing k. We don't know what value of k should we take. If we
Very
know
good.
that,
Anything
then
else?
everything. Yeah.
And
Another is that it doesn't
we,
learn.
Okay, it
It
learns
doesn't learn
yeah,
probability.
weighted
it
on
does
the.
not learn any
Okay, and because of that, do we have any problem if it doesn't learn weights?
Yeah, we will have to call it all the time. It will be computationally very expensive.
Very good. So those are some disadvantages of k-neighbors classifier. Are there any advantages to it?
It classifies well, and it's fairly simple to implement with a simple logic,
Okay.
not too much complexity.
Okay. So yeah, the two one of the points that is valid is that it is simple to implement. The other is it is also very easy to interpret. So you can tell a reason as to why the predictions have been made as they are. Okay. So that is your k-neighbors classifier. The one more that we have is softmax regression. So softmax regression, we've discussed this previously as well. It's kind of an extension of your logistic regression itself, but this time I'm going to have multiple classes in some sense. So I would recommend that you can look for the multi-class setup here. So this was once again covered in the live session. So you can go to the live session as well to see it. Let me just point to the yeah. So this is the specific one. So multi-class previously, now this is being changed also. So it is going to always going to make use of this setup. But otherwise, previously it used to be that you had an option of training with OBR, and you're going to have different ways in which you can implement the logistic regression model that is extended to a multi-class setup. And when you do it for a multi-class setup, you come to softmax regression, and the details of it more I've covered in the specific live session. So you can go there. If you recollect, we ended up seeing how the formula for logistic regression changes when we come to the softmax regression case. That is, instead of finding one say probability value, we are now going to do it for multiple classes. We are going to get different probability values. So that is roughly softmax regression. And yeah, that is the main content for week 8. There are some other things like in under large scale SVM.
excuse me, sir.
Uh, yeah,
Sir, I have a basic doubt. So we have so many algorithms, but when we are doing it in real life, how to choose which algorithm? I mean, so we have to create all different models and see which one is performing the best.
right. A lot of the approach in practice is an iterative approach. So not always are we even going to continue using these methods. So in fact, a lot of it will be done by deep learning, but there is still prominent amount of classical models used, especially in the case of say tabular data or in places where you need high interpretability. These are still in use. And coming to which models do well, there's two things. One is uh, sometimes you're okay with giving up model performance if it means that you're going to get better interpretability. Like for example, decision tree and KNN are extremely interpretable, but their performance might not be as good as say something like an ADA boost or boosting or ensemble methods basically. Now, the other thing is that you're always in these things. It is about trying these different things. So you might try out many different models, and depending on what performs well, you will take it. You'll again do hyperparameter tuning, and you'll go ahead. Now, in practice, what we end up seeing is that boosting models do well. Specifically, most people end up using either say XG boost or light GBM and so on. Some others include something like stacking classifier, or basically your stacking methods. Okay. So the general idea, try out these different models. Like your decision tree and all are very simple. So unless you have a specific use case, you might not see people using it as much. All right. So that is the main
Sir, a
content
bit out
from
of context
DK.
question.
Yeah.
Uh,
So you have a
I
question?
wanted to know like how good is fast FM, light FM basically for recommendation model? Like, is it good to learn about it and use it in recommendation model or
It's light FM, is it?
yeah, light FM fast metrics,
Okay. I
factorization
specifically have
mostly.
not used it, so I do not have
Okay,
much idea about it.
okay, sir.
And sir, do you know about the EM algorithm that was described in MLT week 4?
Yes, the
So
expectation maximization is a very common algorithm that has led to a lot more development
Yeah,
of
but
MLP.
we haven't covered it in this course, right?
Yeah, so it's not there in MLP. So the thing is, these are very easy to use, straightforward methods, and your EM algorithm it does something slightly different. So it goes through two steps. First, you have your expectation, and you have your expectation step, and then you have your maximization step. So these are some things you might learn more. There is a subsequent course coming up where you might learn more about these things, and their implementations are also not going to be very straightforward as such. Okay. Now, what you do in MLP is you can think of it as more of a black box setup, wherein you roughly you know how the model works. You are given these different parameters that you can tune, but you will not always have full control. Like for example, you have your solvers and optimizers. So there are different methods with which you can solve the given problem at hand. So you're going to have an equation which you need to optimize, which you need to find the say the minimum value for. And to do that, you might use different gradient descent methods. You might use these different solvers. But specifically, how these implementations are done are again not something in your control. Now, EM algorithm, while it is very powerful, it is used even in things like bioinformatics. You see it being used a lot. But the specific implementation is not covered in this particular course, and it is beyond what we see in SQL. So more about it, you might see it in a subsequent course. Okay.
Which subsequent course, sir, exactly?
There is a bit of it. I think it should be there in
Deep
statistical
learning?
computing as well. No, no, it is in your degree level courses. You could
Yes.
have a look at the contents of statistical computing, and there might be a bit even in the algorithms for data science. It's a new course that's coming up, so it might be there in one of those. Okay.
Okay, sir.
You'll see a bit of it even in the course algorithmic thinking for bioinformatics. It'll be similar to what you have seen in MLT. Anyway, coming back to the task at hand. So yeah, we are done with week 8. Uh, Amartya, can you cover week 7 now?
Yes, yes, sure. So, yeah, week 7, the major topics which were covered in week 7 were on this naive based algorithm. So, just share my screen. So majorly the question set are like will mostly come from whatever has been covered in the live session part. So if you have attended the live session, you have seen mostly that how we are using this naive based classification model to classify the spam and ham emails. Okay. And what are the different types of night-based algorithms which are already there in sklearn, like this multinomial NB, Gaussian NB, complement NB, Bernoulli NB, and in which kind of the situations which we are going to use which kind of night-based classifier, like in what kind of data set. If you are working on if you are working on some kind of text data set, we will be using like multinomial NB. If you are using some kind of data set which has some Gaussian kind of distribution or some kind of Bernoulli distribution, we will go with this Bernoulli NB or with the Gaussian NB. So okay, let me just open this documentation part. So um, maybe just okay. That this is the naive based documentation, and as you can see, this is the naive based formulation, which is pretty much recommended you should know before jumping into the different kinds of problems, like how this things works on, like what is the internal maths behind all these kind of things. So basically so what are the different types of naive based algorithm which I was saying, like the first here comes is the Gaussian NB, Gaussian naive based algorithm. This is the formulation, and as you can see, uh, this if we click this, it will have a more elaborative description of Gaussian NB, and only see this some things are written over here, so you can just go over this a little bit, not the entire documentation maybe, but Okay, no, this part is not important so much. Okay. Okay. Anyway, so this is in which kind of situation I was saying that you will use a Gaussian and a naive Bayes algorithm. In which kind of techniques you are using going to use this multinomial naive Bayes algorithm here, as it is specifically written that multinomial NB implements the naive Bayes algorithm for multinomially distributed data, and is one of the two classic naive Bayes variants used in text classification, where the data are typically represented as word vector counts, although TF-IDF vectors. Okay, so yeah, these things you need to know. Here also it is written adaptive of the standard multinomial Bayes algorithm, complement naive Bayes, and here it is Bernoulli's naive Bayes algorithm, and this is the categorical naive Bayes algorithm. But mostly you need to know like this four categories, four or five categories. This Gaussian NB, multinomial NB, complement NB, and this Bernoulli's NB. And of course need it's yes, anyone?
Sir, will we have questions on TF-IDF vectorizer?
Yeah, I'm going to go into that part only. Okay. Anyway, so what I was saying is that you need to understand first like how when you are using gosh this multinomial NB or any kind of uh, naive Bayes algorithm, how you are going to use those kind of algorithm to detect the spam or ham emails. And as you said that TF IDF these things we have used, so I think here we have used vectorizers. So those kind of things are needed to how to handle this data set, how to convert the text data set into some kind of numerical model, and then use it for classification task. So if you have gone through this live session, and if you have this Google notebook with you, then it's pretty much easy. Just you have to go through this whole notebook once along with the documentation, and you just need to play around with the documentation and just tweak these values. So nothing comes outside of whatever has been taught in this live session, but of course you need to know also some topics related to, which are specified in this documentation, like the parameters which are passed into this naive Bayes algorithm and all these kind of things. So if I click this Gaussian NB, this priors equals to norm and all these kind of things, it's you should know how to run this algorithm, how to run this CLF dot fit comma x comma y and all these kind of things. These things are needed. Okay. So yeah, this is mostly what will be there in week 7. Just go over through this documentation once, and how this factorization and all these kind of things works. Okay, and yeah, and like in which kind of scenarios you are going to use which kind of my best algorithm. This is the thing. Any question till this far? Anyone?
So when we see the documentation like Gaussian NB, and all these like multinomial NB, where we predict the value of some points, but when we doing a collab, it is okay to find the value. But when we doing like it in the examination, that question is coming. That is some tricky part. Like,
No, nothing is
uh,
tricky. So that only I am saying that you are not going to use. Suppose I am saying, what should I just say? Give an example. So if
so
you,
you see one example like Gaussian and the
yeah,
documentation.
Gaussian NB and all these examples are already there in this collab notebook, and which was shared over here. Nothing will be asked for your experimentation part. it will test whether you know, whether you know in which kind of situations which kind of naive base you need to work with, and like how does a naive base algorithm works internally, how to preprocess the data, and some of the scoring metrics as well, accuracy score, confusion metrics, and all these kind of things.
Yeah, actually, they ask the predict the value of that.
No, prediction won't be there. Prediction won't be there because then you have to go through the maths and all these kind of things. So yeah, prediction part won't be there, but of
Like
course it's
this example, you left it. Just go down.
in this part
No,
here.
no, sir. In documentation,
Yes,
uh, uh, like not this one. You go down.
this one.
No, no, sir.
So there is no example as such. I think you are talking about these examples. If I click over here, some things will come up like this one.
Yes, 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 yes.
Yeah, so these things you don't need to know, yeah, how these things internally works and all, means so if you have this kind of data, this you have this kind of data, so the question won't test your mathematical skills, like how if you have been provided a data, then how you are going to predict what could be the output and all.
Like making a four quadrant and put the value and then
No,
divide.
no, those kind of things won't be there. Those kind of things won't be there.
So,
But
sir,
of course,
how to predict the values like points minus 0.8 minus 1?
which word you are saying?
Sir, in like,
This one?
no, sir, not this. Like this one. Yes.
Yeah, so if you are trying to do this kind of predict, right, you have to implement all these kind of things previously. So that only I was saying that you don't need to do any kind of mathematical stuff so in the exam hall. That only I'm trying to say, right? So you have to do the internal maths and all, then you can predict, right, this minus point 0.8 and minus 1, what will be the value. So those things won't be there, I'm saying that.
So, sir, how to find predict the value? That's my question.
Yeah, then you have to do the whole calculations and all. Only after that you can do the this prediction, right? Now
But
if I
sir,
have
these
to
kind of question, sir, it can I please ask? So,
yes.
sir, these kind of questions have been asked to predict. Actually, I looked at 2022 term paper, and these questions have been asked. I'm not sure whether in recent years the pattern has changed, but in 2022 that I was looking at, so at least I
Even in
noticed such
the
question.
previous year papers, PYQ, I'm seeing that this
Mm-hmm.
type of questions asked.
These kind of questions were asked.
Yes,
Yeah,
sir.
then you can have a glance over it, but this time it's all these kind of things are not completely coming up, I will say. There maybe you can consider that there is a small change. Okay.
Okay, sir.
Yeah, but of course it's not it's always always recommended if you know all this mathematical stuff or what is going on behind. Okay. Yeah, that's all for the week 7. So Aniruddha, can you go for the week 5, sorry, week 6?
Yeah. So coming to week 6, it first introduces you all to the classification paradigm itself. So you have classification functions, and yeah, is there a question?
Sir, can I please check what will be the weightage across weeks?
So weighted across weeks, yeah, I think it is more or less similar. All the weeks have similar weightage. So whatever we have covered now. So anyway, weeks 1 to 4 we are not going to be covering today, but it is still questions will be asked from that as well. You can refer the quiz 1 revision session for it. And Weeks 5 to 12 is weeks 5 to 11 is what we are covering today. From 12, we are not going to be having any questions. So 5 to 11, whatever we are telling are important today, you can focus on that. Again, coming to weightage, it is more or less going to be similar weightage across weeks. Okay. So yeah, so week 6 introduces you to the classification paradigm in general, and then we have the two important algorithms we have are logistic regression and perceptron. So primarily logistic regression, you should many of them sort of think of this as a regression algorithm. It is sort of like a misnomer, and it is something you have to be aware of. So logistic regression, you can use it for classification tasks, and the important parameters in this that we are going to see is one is penalty. So this is whatever either you want to apply lasso or rich kind of a penalty if you want to put it. These are your options: your L1, L2, and elastic net. Elastic net is when you want to include both of them. And then some of them that you need that are important are regularization strength again. So recollect this. We also saw one version of it in SVM as well. So what you should note is it can be different in the two of them. It is something I'll ask you to look into. And you should know what happens when I increase or decrease this. Does the regularization strength increase? Does it decrease? You see in this particular case also, C is inverse of regularization strength. So the more I increase this, the lesser the regularization I will have. And if I have lesser regularization, then there is a chance that my model might be overfitting also. Okay. And then there is class weight. So this is one of those which you can use to provide different weights for different classes. This is something that is good if you have something like imbalanced data sets. Then you have solvers. So we discussed this briefly before as well. So these are your different ways to optimize things. By default, it takes LBFGS, but there are a few more. You don't need to know the math of all these things specifically. Just know that these are the different solvers that I can use. Some information that is given here are what is applicable where. You don't need to memorize this, but once again, know that these are the different methods that I have. Then you have max iter. So max iter is when I have, say, I have an optimization problem with solvers, and if I cannot converge, if I do not converge, if I want to stop my model somewhere, then I can specify this. So if you guys have used logistic regression in practice, in many of these data sets, you might see a warning that comes up with regards to convergence. So in such cases, you can give a higher value and see if your model converges by then. Okay. Multi-class, as I mentioned, is now sort of being deprecated in this current version. So wherein if the number of classes that you have in your data set is greater than or equal to 3, it will automatically treat it as a multi-class problem, and this will be similar to whatever content we currently have on softmax regression. So the general idea is how it does with one versus rest classifier. This is what was there before, so you can have a look at this as well. And one versus rest and one versus all also is something. One versus one and one versus rest also is something that we discussed in the live session when we covered the week, so you can go there as well. Okay, so coming back to this, primarily we once again have to know the basic working of logistic regression. The important parameters I would say are penalty, the value of C, class weights, solver, and max iter. Okay, so these are things that you mainly need to know. Then coming to perceptron, perceptron is also a classification algorithm. It is an algorithm in which we try to separate out the data into two classes in case it's a binary classification set. So once we have our decision boundary somewhere, we check how the decision boundary performs on a particular point, and then we update it based on that. So perceptron might not always, if the data set is not linearly separable, we might not always have the perceptron. It will not be able to basically separate out the two. So in that case also, we are going to stop it ahead of time. So which is why we have your max iter, tolerance, and so on. So coming to things, once again, penalty, which we have kept seeing, lasso, ridge, or elastic net. So this is important. And then I would say learning fixed intercept, max iter we saw again. And then we have tolerance. So tolerance is if the loss that we have, if it does not keep reducing, so ideally when we keep training our model, we want the loss to keep reducing. If the loss does not reduce in subsequent iteration, so and specifically this is what we give. So if the difference between the losses, if it is not greater than this tolerance, then we want to stop our model training there itself. That means basically our model slowly, bit by bit, it is changing, but we don't have significant gains. Okay. So mainly from this, I would say from perceptron, again, know the basic working of the model, to know about penalty, fit intercept, max iter, and tolerance. Okay. And coming back to this week, it was just an introduction to classification things, and we saw evaluation metrics later in week 9, but I can't stress enough as to how important it is. So make sure you know your evaluation metrics properly. Okay. So that is for week 6. Finally, we'll be having week 5, and week 1 to 4. You can refer the quiz 1 revision session. Amartya will be covering the week 5 part now, and beyond that, take heed of whatever we've told today. So know the basic working, try out a few examples, see the implementations through sklearn, documentation, and so on. And any doubts you have in the subsequent session, we'll entirely keep it for doubt clearing. Okay. Amartya, can you take up week 5?
Yeah. Okay. So yeah, let me share my screen. Okay. So again, week 5 will be also is related to the polynomial regression, regularization, cross validation, tuning, and I think also little bit of the stochastic gradient descent. So these things are quite deeply covered in the live session, so it's pretty much advisable to go through this again through this collab notebook which was shared. So here you will see like how to use this polynomial regression, how to use regularization, regularization as in like L1 regularization, L2 regularization, and elastic net and all those kind of things. So let me just open this documentation. So polynomial regression using sklearn. So yeah, so as you can see over here, this is in, okay, this one. Okay, so pipeline, I think all of you know, like you are, if you are doing numerous steps, it just combines all those things in a one line. So yeah, those things are related. And polynomial features, so this is the thing. So you know, this is the degree equals to 2. What will happen if I increase the number of degrees? So these are the parameters. So you just have to change these values and see like how this curves and all this kind of things changes into the code, inside the code. And when you are dealing with this polynomial features, and after fitting this function, you are trying to introduce some kind of penalty term inside it. So in those cases you will use this L1 or L2. So as if I go a little bit down, then okay, you will see over here, this is the L1 ridge, lasso, elastic net, and all these kind of things. So it's better to go through the documentation part, how these things are implemented in sklearn, and just play around with this Google Colab notebook. And you all, of course you already know that after implementing this polynomial features, we have to fit this function using some kind of SGD regressor or any linear regressor model. And so when you are talking about this SGD regressor, okay, so SGD regressor also, there is this sklearn SGD classify regressor, sklearn documentation. So all these things we pretty much went deep with all these hyperparameters, and it's very much recommended to go through the live session once and try to test out all to change all this L1 ratio or alpha values and all those kind of things, and see how this performance changes over there. And at the end we checked like something like tuning, hyperparameter tuning. So that part is here, I think. So we will, okay, it's not over here, this is in the other notebook anyway. So in the hyperparameter tuning we have something as random search CV and grid search CV. So these things are important, like how these things are implemented in sklearn. And okay, just let me open one by one. Random search CV sklearn. So this is the random search CV, like how these things are implemented in sklearn. This documentation part is very much important, and just go through all this documentation pages. You will get a very much pretty much good idea of to how to work around with this kind of things. Okay, yeah, that's all for week 5, nothing more. So it's like highly recommended to go through this Google Colab notebook and through the live session. It pretty much covers everything over there. Any question till
Sir,
now?
this collab are shared, right?
Yes.
These collab are shared in the supplementary content, right?
Yeah, I think it's shared, and also it is shared in this what is called this Google Meet. This notes is there, right? Google Meets notes over there, it's already shared. So from there you can take this Google Colab notebook. Anyway, I can share it now as well if you want in this meeting chat. I can just paste it over here. So you can go through this Google Colab notebook. I think there is one more Google Colab notebook. Let me just check. I think this is the only one. Yeah, that's the only one. Yeah. So go through this Google Colab notebook. It pretty much covers everything which is required for the exam. Okay. Any more question?
So this not open actually collab, it show error. Notebook loading error.
Now try to check. Is it working now? Okay. Any more questions?
Sir, can you please share the drive link where all the links, all the collab notebooks are saved for other weeks as well, starting from 5th to 11th?
I think that we have to collectively share. So I will have a talk with the other instructors, and then we can look into it.
But so there must be one central drive, right? Some drive where all must have been
Yeah,
saved.
for those things I have to check with the other instructors.
Okay, sir. So when can you share?
By I think by next live session we can form a decision on this. Okay. Okay. Any more questions?
Yeah, so the course
And
material collab link, in case you did not have it already, I've shared. Coming to the individual material that we have done, for most of my weeks, I have not used collab. I've done it in Kaggle Notebook. Plus, I've also mentioned that I would not be sharing the code written there. So yeah, it was. Every session I had asked the students to follow along to the code yourselves, and that we will be discussing subsequently. So anyway, regardless, if you have any questions, you can always ask it in the next session.
Oh,
And sir, are you going to discuss mock in next session? Mock has already been released for Anton.
Mock will take a call on that. So if you have any doubts in that, you can anyway bring it up. But whether we'll do the same paper or not, we'll see it then. So as I mentioned, weeks 1 to 4, you need to go through the quiz 1 revision session. And yeah, if you have any other doubts, you can always post it on Discourse or you can ask it in the subsequent session.
So will the atom like equal to like you release mock?
Are you asking if the mock that is released is going to be similar to how the end term paper
Yes,
will be?
yes, yes.
Okay, so in general, the kind of questions that will be there in MLP tend to be similar itself, but it always is the same thing that it requires practice. In the similar setup, you have to do learn the model, know its parameters, what values it takes, and a brief implementation of it. So apart from that, yeah, usually the setup tends to be similar. So if you've done well with the previous problems, or even if you've seen the mock as well, you can understand that you can expect similar questions. Okay.
Okay, sir.
All right. Okay. Thank you all for joining. We'll see you again in the next session.
thank you all
Thank
for
you.
joining.
Thank you, sir.
Thank you, sir.
Thank you, sir.